Math lesson today, we are going to learn again how to differentiate between proportional and non-proportional relationships. Differentiate means tell the difference. Okay, so by the end of this lesson, you should be able to tell the difference between proportional and non-proportional relationships in tables. Okay, so this is what we've been working on. So hopefully this one's pretty simple. This is basically the same skill that we were practicing last time. So hopefully by the end of this lesson, you're feeling pretty confident. Let's get started. I think this should be a faster lesson because we've been through this, similar materials, and we're just kind of using the same information in a different context or a different situation. Which team will win the race? You have decided to walk in a long-distance race. There are two teams that you can join. Team A walks at a constant rate of 2.5 miles per hour. Team B walks 4 miles the first hour and then 2 miles per hour after that. Create a table for each team showing the distances that will be walked for times of 1, 2, 3, 4, 5, and 6 hours. Using your tables, answer the questions that follow. All right, so let's get started. It's a word problem, so we're going to look for important pieces of information. Okay? Walking a long distance race, there are two teams, okay? Two teams that you can join. Team A walks at a constant rate of 2.5 miles per hour. Team B walks 4 miles the first hour and then 2 miles per hour after that. All right, so our task, this is what we're needed to do. Create a table for each team. So we have our tables for Team A and Team B, showing the distances that would be walked. Okay, so distance for times of 1, 2, 3, 4, 5, and 6 hours. Time and hours. Okay, then using your tables, answer the questions that follow. So first we need to fill in this tables using the information given there. Okay, well, where do we start? Okay, so thinking back, I missed a piece of information that I should have made a note of. Okay, they're walked for times of, so those are our times that we're going to put in our table. We need to find the distances that will be walked for these different times. Okay, so time 1, 2, 3, 4, 5, and 6. Same thing here. 1, 2, 3, 4, 5, and 6. Okay, those are pieces of information they gave us right there. Now we need to use the rates that we are given to find out what the distance will be after each number of hours. Okay. Two teams. Team A. Okay, so Team A walks at a constant rate of 2.5 miles per hour. If it's a constant rate, that means in every situation, the rate is the same, which means this is a proportional, okay, this one is a proportional relationship. That is not how you spell proportional. Proportional. Okay, so let's take a look. So they walk at a rate of 2.5 miles per hour. Okay, so that's 2.5 miles per 1 mile. So every time we go 1 mile, we are also going 2.5 miles. Wow, I'm having a rough day so far. Okay, per 1 hour. That's why we use pencils. Okay, 2.5 miles for every 1 hour. So if we've gone 1 hour, how many miles should we have traveled? Okay, 2.5, right? 2.5. Now, if we've gone 2 hours, how many miles? Well, if for 1 hour it's 2.5, then 2 hours should be this 2 times, because we've traveled 1 hour 2 times. So 2.5 miles 2 times, or 2 times 2.5. Okay, 2.5, 2 times is 2 times 2.5. Okay, so you can pull out your calculator and do that, or maybe do some quick mental math. and that will be 5.0, or just 5. Because anytime that decimal has nothing after it, or a 0 after it, okay, or all zeros after it, that's okay to get rid of it. Now 3, okay, that should be, all right, this 3 times, because we've walked in 1 hour 3 times, so we also need to walk 2.5 miles 3 times. So 2.5 3 times is 3 times 7, or 3 times 2.5, which is 7.5. Okay, and so we can continue filling out the chart this way. For 4 hours, that means, okay, so 2.5 in 1 hour. If we're doing 4 hours, that means we're doing this 4 times. 2.5 times 4, or 4 times, is 10. 5 would be 5 times 2.5, or 12.5. And lastly, 6 times 2.5 is 15. All right, so we've got one chart filled out there. Now this one, things are a little different because it says Team B, okay, walks 4 miles the first hour and then 2 miles per hour after that. So this is not a proportional relationship because it is not going to increase. As we increase by 1 hour, it is not going to increase, this number will not increase the same every time. Okay, that was kind of a weird way to say that. Basically, here, if we started at 0 and 0, and every time we go up by 1 hour, we also go up by 2.5. Okay, 2.5 miles. That will not be the case in this relationship because it says they walk 4 miles in the first hour and then 2 miles per hour after that. All right. So after 1 hour, if they walk, okay, in the first hour, how far will they have traveled? Well, let's look back here. They walk 4 miles the first hour. So now they've traveled 4 miles after 1 hour. All right. Then, after the first hour, then they start to travel 2 miles per hour after that. So then, after this first hour, now they have a constant rate of 2 miles per 1 hour. Okay, so now it's predictable. However, because just that one point is not following the rate, it's not proportional. So after that, if they're going every hour, they're traveling another 2 miles. Okay, so it's going to be 4 miles plus, okay, the next hour they travel 2 miles. So they traveled 2 miles in that second hour plus 4 miles in the first hour. Now they've traveled a total of 6 miles. Okay, 1 more hour passes and they walk 2 more miles. Puts their total at 8. They walk another hour, 2 more miles, puts them at 10. Another hour, 2 more miles, puts them at 12, and that last one will put them at 14. And now we have completed our chart. Okay, and this one is not proportional. All right. So this is not proportional because even though it looks like it goes up by 2 every time, this first one does not fit in with the rest of the information there. Okay, even though every time it goes up by 2, if they're traveling 2 miles per hour in every situation, then after 1 hour they should have only traveled 2 miles. But this told us they traveled 4 miles in the first hour. All right. Letter A here at the bottom says, for which team is distance proportional to time? We said Team A. And why is that? Because every single piece of information in this chart matches the idea that in 1 hour they travel 2.5 mile. In 1 hour they travel 2.5 miles. In this case, even though it looks like they're going an extra 2 miles every hour, this first place, if they were only traveling 2 miles every hour, then they should have only been at 2 miles at this point. That is the difference. Okay. And so there's our reasoning as well. Let's scroll down. I know this isn't going to match up. Let's see what other questions we have. Explain how you know distance for the other team is not proportional to time. It's because of this first piece of information right here. That first piece of information where they traveled 4 miles. At what distance in the race would it be better to be on team B than team A? And explain. Okay. At what point would it be better to be on team B than team A? Is that how I read that? Or is it the other way around? Yeah. When is it better to be on team B? Okay. If you're running a race, when would you rather be on this team? Well, let's just look at the distances. Let's see. So after 1 hour, they're clearly winning. They would have traveled more miles. After 2 hours, they're still winning. After 3 hours, they're still winning. After 4 hours, they're tied up. Okay? And then after 5 hours, this team starts winning. Because they're traveling they're traveling faster overall. This team traveled fast at the start and then slower after that. So if I was looking at this, I would say anything less than 4 hours, any time less than 4 hours, I want to be on team B. Okay? Because that's the point where they finally catch up, is exactly at 4 hours. Okay? So at less than 4 hours, I want to be on team B. Because their overall rate is lower. Once they start running 2 miles per hour, this team's going to catch up slowly over time. Okay, it's only because they got a head start of basically 1.5 miles because they ran faster for that part. All right, let's look at our other 2 questions. Well, actually, we have quite a few more questions. Okay, let's see. If the letter D, if the members of each team walked for 10 hours, how far would each member walk on each team? If the members on each team walked for 10 hours, how far would each member walk on each team? Okay, well, we can just continue our chart out. So for this one, it would be really simple. We can just multiply 10 times 2.5 because that's a constant rate. This one doesn't have a constant rate, so we can't just multiply 10 times 2. That won't work, okay? Because of this spot right here where we have a non-proportional relationship. There's a way we could work around that that maybe we'll investigate at a different time. But for now, let's just stick to what we know, okay? So 10 hours walking 2.5 miles per hour would be 2.5 10 times. Because 1 hour, 10 hours, that means they can do this 10 times. So 2.5 times, I shouldn't use x because that's confusing. Okay, 2.5 times 10 equals, that should give you 25. Remember when we talked about fractions and decimals and things? When we multiply a number by 10, it's the same thing as moving that decimal place over 1 spot. Okay. So let me get rid of that. Okay. And over here, we can't just use multiplication. So let's just continue our addition way of doing things. So then, let's see, at 6 hours, 14 miles. At 7, then they should be at 16. At 8, they should be at 18. At 9, they should be at 20. And then at 10 miles, they should be at 20, or 10 hours, they should be at 22 miles. So at 10 hours, Team A will be at 25 miles, and Team B will be at 22 miles. Sorry, the screen's getting pretty full. I might have to erase some things. E, will there always be a winning team no matter what the length of the course? Why or why not? Okay, if the length of the course... will there always be a winning team? Yes or no? Well, if I'm looking here at 4 hours, these teams should be tied up exactly, right? They've both traveled exactly 10 miles. So if the distance is exactly 10 miles, then these teams should, based off of what we're told here, be in a complete tie. Okay, so that answers that question. If the race is 12 miles long, which team should you choose to be on if you wish to win? If the race is 12 miles, which team would you want to be on to win? Why would you choose this team? Okay, I think we talked about this enough that you should be able to answer that question on your own. If the race is 12 miles long, okay, which team do you want to be on? Because it looks like after 5 hours, this team will have gone 12.5 miles, this team will have gone 12 miles. So I'll just ask you the question, who would get to 12 miles first? Okay, and that'll help you answer that question. Next one. How much sooner would you finish on that team compared to the other team? Okay, if the race was 12 miles long, how much sooner would you finish? That's a really tough question. We'll skip that one for now and move on to the exercises. All right. Clear off my board here. All right. Bella types at a constant rate of 42 words per minute. Is the number of words she can type proportional to the number of minutes she types? Create a table to determine the relationship. Okay. So using this rate, is the number of words she can type proportional to the number of minutes? Are minutes going to be proportional to words? Okay, you should know before actually doing the problem because it says it's a constant rate. So in all the examples, if it's a constant rate, that means all the examples should be based off of that rate. And so yes, it would be proportional. Okay, but let's do the work and fill in the table. Well, her rate is 42 words per minute. Okay, that's a piece of important information, constant rate. And then this is the question we need to answer. Is the number of words she can type proportional to the number of minutes? And then create a table. All right. So after 1 minute, so her rate is 42 words per 1 minute. So if she she writes for 1 minute, she should have 42 words. How about 2 minutes? So she can do this 2 times. 42 words times 2, or 2 times. That should be 84, because 42 times 2 is 84. Okay, how about 3? 3 minutes. Okay, so if she does 42 in 1 minute, she can do this 3 times. So 42 3 times is what? Well, let's see here. 42, you can either take out your calculator or do it that way, but we should get 126. Now, 6 minutes. Well, she can do that in 1 minute. So if we do it 6 times, 42 6 times, because 1 times 6 is 6, okay, 42 times 6 will give us our answer. So 42 times 6 should be 252. And lastly, 60 minutes, if she's typing a constant rate, 60 times 42 should be 2,520. Okay, you might be wondering, how did I get that answer so quickly? Well, 6 to 60, the difference is multiplying by 10. So if I have my answer for 6 and I need my answer for 60, I can just multiply this number by 10. And we can do it on a calculator just to make sure. 60 times 42 equals, okay, and there I got 2,520. All right, and so we created the table. Is this proportional, or is this relationship proportional? Yes, because it's a constant rate of 42 words per minute. No matter how many minutes she types, she will always get 42 words per minute. That is what the problem tells us. Is that realistic for real life? No, because your hands will get tired. But the problem says she types at a constant rate of 42 words per minute. So that is what we expect when we're doing the problem. Let's take a look at the next one. Mark recently moved to a new state. During the first month, he visited 5 state parks. Each month after, he visited 2 more. Complete the table below and use the results to determine if the number of parks visited is proportional to the number of months. Okay, let's find important information. Mark recently moved to a new state. Nope. Okay, the first month, he visited 5 state parks. Each month after, he visited 2 more. Complete the table below. That's what we need to use. Use the results to determine if the number of parks visited is proportional to the number of months. Use the results to determine if the number of parks visited is proportional to the number of months. All right, we got our information. Where do we start? Okay, I'm just looking at a chart. What am I using? Now that we found the important information, we found our numbers, and we found what it's asking us to do, where do I start? Okay, let's fill in this chart. This is saying, after 1 month, how many state parks did he visit? Let's go back to this problem and look for information. Okay, recently moved to a new state. During the first month, he visited 5 state parks. So after 1 month, he visited 5. Okay. Each month after, so we're done with this piece of information. Each month after, he visited 2 more. Okay, so each month after the first one, he visited 2 more. Okay, so he's visited 5, and then after 1 more month, he should have visited 2 more, right? So let's see here, number of months. So 1 month he visited 5. After 2 months he visited 2 more. So 2 more would put him at 7. Okay. Then after a 3rd month he visited 2 more. So that would put him at 9. Okay. Now we have to fill in this. Okay. So 23 state parks. How can we get that answer? Okay. And this is going to be a tough step. Okay, I skipped a problem earlier because I wanted to skip it for now, but we're going to talk about the same concept we were going to look at before right here. Okay, so I don't think you can't do it. Okay, I do know you can do it. I just wanted to save that step for here. Okay, so number of months and the number of state parks. So in the first month, okay, then he went to 5 state parks. Every month after that, then a rate starts, right? Then after that first one, he visited, and then he visited 2 state parks per 1 month. So if it says he visited 23 state parks, if I just count up, okay, so let's say 2 state parks, 4, 6, 8, 10. Okay, 10 state parks would take him 10 months, just counting in my head. Then 12 would be 6, 14 would be 7, 16 state parks would be 8, 18 state parks would be 9, 20 state parks would be 10, 11 state parks would be, 22 state parks would be 11, 23, now he's not going to 2 in a month. Okay, so now this is starting to get confusing, right? All right, well, here's what we're going to do. So if we know that he went to 23 state parks, and we needed to find out how many months that took him, think about this. The first month, he visited 5 state parks. So what if we subtracted 5 from 23? 23, let me write that larger on the board. 23 minus 5. What would that tell me? Okay, the first month he traveled went to 5 state parks. That equals 18. 23 minus 5 equals 18. What can I do with that information? Well, if he went to 5 in the first month, that means all the months after that he went to 18. Because he went to a total of 23, 5 in the first month. That leaves 18 after that first month. Now we can use our rate. 2 state parks per 1 month. Okay. So now we can use our rate. Okay, so the first month, so in 1 month you go to 2, 2 he would go to 4, 3 he would go to 6, 4 he would go to 8, 5 he would go to 10, okay, then continuing here. After 6 months you would go to 12, 7 months you would go to 14, 8 months you would go to 16, 9 months you would go to 18. So after that first month, he went to 2 state parks every month. So counting up, so in 9 months he went to 18, okay, that equals the number left after the first month. So why did I subtract that number? Why did I subtract 5? Because that was the only piece of information that didn't fit in with our rate. Because after the first month, he only went to 2 state parks per month. So if I get rid of this piece of information and just forget about that for now, okay, that doesn't sound like a good thing to do. But in this situation, it'll work. Because then we're only left with, okay, now he traveled to 18 state parks in all the months after that. Well, all the months after the first one are 9. So he traveled to he traveled for 9 months to these different state parks, plus that first month where he went to 5, which is a total of 10 months. Because it took him 9 months to go to 18, plus 5 in the first month. Visited 5 in the first month. And then he would have to go to 18 more to get to 23 total. Okay? So by subtracting 5, that gives me the number that I can use with this rate. Because this 5 doesn't fit in with our rate. So if we subtract that, and remember, he did 5 in the first month. Okay? Another way to look at it is this. After 0 months, he had to visit 23 more state parks. After 1 month, he had visited 5, so he had 23 minus 5 left to visit, or 18. Then after the next month, he had 23 minus 7, or 16 more to visit. 23 minus 9, or 14 left to visit. Okay, so that's what I did here. I just subtracted that first month and then put the rest of it into using our rate here to determine how many more months he would have to go to state parks for. Okay, you might be feeling a little bit confused right now. Okay, and we are just about finished, but I would like to, I'm going to pause for 1 second. I'll talk to you in a sec. All right, because we're running out of time on this lesson, here's how I would like to finish. The next problem below, okay, right here says the table below shows the relationship between the side length of a square and the area. Complete the table. Then determine if the length of the sides is proportional to the area. Okay. Again, this is a more difficult question, and this is going to be a bit of a challenge. Okay. And actually, hold on 1 more second. All right, here's the game plan. Your exit ticket for today, you're not going to have a full assignment. However, you will have a skill on IXL. Okay, you won't have a full assignment. I would like you to complete problem set just number 1 as your exit ticket. Okay, and I will use that to determine kind of where we're at. But I want to spend another day on this lesson because this is a challenging one. Okay. So if you're still just a little bit confused, it's okay. You should be able to do this one using some of the information from the earlier part of the lesson and from what we discussed yesterday. Okay, So complete that one. You can submit that one inside of Google Classroom. There will be a worksheet or a Google Doc for you to answer there, and you can complete that assignment there. All right, and then make sure that you also go into IXL and complete the new skill that will be assigned about proportions.